All right, so evaluating functions. And again, I'm looking at this handout that we were dealing with. So the ones that are checked, we've already done. So let's look at this function f of x equal 3x minus 7. And part C, we already did C. Part D, you want to find f of x plus 4. All right, so f of x plus 4. Okay, so remember, f of x stands, remember we're dealing with function notation, but f of x stands for what letter that we dealt with previously? Y. All right, so you want to find f of x. And remember that is read f of x, not f times x, f of x. Of here does not mean to multiply. And so if I want to find f of x plus plus 4, f of x plus 4, I'm going to underline this x plus 4 because that's what I'm going to substitute into my function wherever I see the variable x. So I'm going to get f of x plus 4 is going to be 3 times, in parentheses, x plus 4, because that's what x becomes. I'm going to substitute, in place of the variable x, I'm going to substitute x plus 4, and then minus 7. All right, so that's what I'm at this point. Okay, so once you get to that point, then you can distribute. You're going to get rid of the parentheses. So I get 3x, and then 3 times 4 is 12 minus 7. And they combine like terms, I get 3x, and then 12 and minus 7 is 5. And so that is f of x plus 4. So that's your answer. So notice I am evaluating at an expression, so I'm going to end up with an expression. I'm not going to get just a number. I'm going to end up with an expression. Okay, and then E, you want to find f of x, 2x minus 1. So I'm going to go ahead and rewrite the function again. So my function is f of x equal 3x minus 7. So I want to find out if my function is 3x minus 7, then what is f of 2x minus 1? So I already know what f of x is. F of x is 3x minus 7. But I want to find out what f of 2x minus 1 is. So in place of the variable x, what do I substitute? 2x minus 1. So underline if you've got to, and then draw a circle, an arrow to that variable x. And so then this becomes 3 times x, and what does x become? 2x minus 1, and then minus 7. And so distributing, I get 6x minus 3 minus 7. So therefore, f of 2x minus 1 equals what expression? 6x minus 10. Okay? All right, now number 2, you're given this function this time. So number 2, you have f of x equals this quadratic. So this was a quadratic function. The previous one was what kind of function? What kind of function was this right here? Linear. That was linear. If you were to graph it, it would be a line. If you graph number 2, which we'll do in a section coming up, but if you graph number 2, that's going to be what kind of graph? You had last semester, you had beginning of this semester. Parabola. It's quadratic. You end up with a parabola. All right, so in part B, you want to find f of negative x. So I know what f of x is. F of x is this function right here. It's 2x squared minus 5x minus 6. But I want to find what f of negative x is. So in place of the variable x, and how many times do I see the variable x on this right-hand side? Twice. So in place of this variable x, I'm going to substitute what expression? Negative x. And so I get 2 times, in parentheses, negative x squared minus 5 times, in parentheses, negative x, and then minus 6. So that's where I'm at. Now I've got to get rid of those parentheses. What is a negative x times itself, because that's what negative x squared means. Negative x times negative x is what?
X squared.
It's x squared, not x. X squared, right? So that becomes 2x squared. So 2 times a negative x squared becomes 2x squared. A negative times a negative is a what? Positive. X times x is what? X squared. When you multiply like bases, what are those exponents? You add them. You had that 2 semesters ago. In fact, when you FOIL, what's x times x? X squared. So don't say x. You FOILed last semester. You dealt with properties of exponents the semester before. What's negative 5 times negative x? Positive 5x, and then minus 6. So that is f of negative x. That's what you write. So f of negative x is 2x squared plus 5x minus 6. Now, all this is going to be important because either tomorrow or the day after, we're going to talk about symmetry. And so symmetry is going to involve you having to substitute a negative x. So make sure you remember how to do that. So you're going to see why we're going to substitute a negative x at some point. But all this plays into what we're about to do. Everything builds upon each other. All right, C. So if you know how to do B, then you should be okay with C. So C is f of 3x. All right, so I'm going to go ahead and rewrite my function so I can draw that arrow. So f of x is 2x squared minus 5x minus 6. All right, so again, wherever we see the variable x, what am I going to substitute? 3x. So underline this if you've got to, and draw an arrow to those x's that are on the other side. And so I'm going to get 2 times in parentheses. What do I put inside the parentheses? 3x. What do I do to that 3x? Squared. Minus 5 times x. What do I put there? 3x. And then minus 6. So wherever I saw the variable x, it became what I want to evaluate it at. Now you got to do some work. So let's go back and deal with this 3x squared. 3x squared means what? 3x times itself. Well, what is 3x times 3x?
9x squared.
9x squared. So that becomes 2 times 9x squared, right? Okay. Now what's a negative 5 times 3x?
Negative 15.
X minus 6. And then what's 2 times 9x squared? So I get 18x squared minus 15x minus 6. So that is f of 3x. So that's what we put in the blank. So f of 3x would equal that expression. So remember, whenever you substitute an expression, you end up with an expression. All right? Now let's look at D. Okay. So D, you have this now. So let me go ahead and write the function again. So my function is f of x equal 2x squared minus 5x minus 6. All right. And I want to find f of x plus 2. All right. So what will I be substituting? What variable will I be, what expression will I be substituting?
X plus 2.
X plus 2. So wherever I see the variable x in my function, and I see it here and here, I'm going to substitute x plus 2. All right, so then I get this. Notice the steps. Notice your steps. So you can say, I'm going to get 2 times in parentheses, what do I substitute?
X plus 2.
What am I doing to that x plus 2? Good. Minus 5 times in parentheses, what do I substitute? X plus 2, and then minus 6. So that's where I'm at. Okay? All right, so just like the previous problem, when I went here and I said 3x times itself, well, 3x is a monomial. So that's kind of easy to deal with. 3x times 3x is what? 9x squared. Okay. When I go here, though, that's x plus 2 times itself, right? So, right, if you look at it, that's x plus 2 times x plus 2. What comes into your mind if I want to multiply this out? FOIL. You're multiplying two binomials. So here, that was not the FOIL method because that's just 3x times 3x. Everything is a product. 3 times 3 is 9, x times x is x squared. Here, that's a binomial. So a binomial times a binomial, you can use the FOIL method to multiply that out. So x times x,
X squared,
what's the outer?
2x.
All right, now remember, those two binomials are the same. So what do you remember about the outer and the inner? They should be the same as well. So what's the inner? 2x. And what's the last? 4. So when I combine my like terms, x plus 2 times itself is going to be x squared plus 4x plus 4. Now, all I found was this. That's all I found, right? But what else must I do to that expression I just found? Multiply by 2. So this is where I would do this. I would say 2 times parentheses, write this trinomial, x squared plus 4x plus 4. Now over here, how do I deal with this part? Distributive property. So I get minus 5x, and then what else? Minus 10, minus 6. Now how do I deal with this part? Distributive property. And so I get 2x squared, what else? Plus 8x plus 8, and then just rewrite everything else over, just like that. And now what's the final step I must do? Combine like terms. So therefore, f of x plus 2 is going to equal 2x squared. What about the x terms? 8x minus 5x plus 3x. And then your constants, there are 3 of them. 8, negative 10, and negative 6. Minus 8. Okay. Are we going to do one more like number D, like letter D rather. So let's look at E. Look at E. So again, my function is 2x squared minus 5x minus 6. And I want to find f of 3x plus 4, right? Okay. So what am I going to be substituting?
3x plus 4.
3x plus 4. So wherever you see the variable x, I see it here and here, I'm going to be substituting 3x plus 4. So I'm going to get 2 times in parentheses, what do I substitute? 3x plus 4. But what am I doing to that 3x plus 4? Squaring it, because that's what that says. Minus 5 times x, what do I substitute? 3x plus 4, and then minus 6. So it does help if you underline things and draw arrows. Okay, now you got to simplify as much as you can. So look at what's being squared. What is being squared?
3x plus 4.
3x plus 4. So let's kind of deal with that. Let's go off to the side and deal with that 3x plus 4 squared. You got to remember that 3x plus 4 squared means 3x plus 4 times itself. So how do I multiply those two binomials? FOIL. So what is 3x times 3x? 9x squared. What is the outer? 3x times 4? 12x. What's the inner? 12x. They better be the same because you're multiplying the same binomials. And then what's the last? 16. Combine like terms, what do you get?
9x squared plus 24x plus 16.
Okay, good. So that's what I get here. Now, what is it that I've found? 3x plus 4 squared. What must I do to that trinomial that I just found?
Flat times 2.
Multiply by 2. So then what you should do next is say 2 times in parentheses 9x squared plus 24x plus 16. And then let's distribute the negative 5. What do I get? Minus 15x minus 20 minus 6. Okay, what else do I need to do? Distribute the 2. So I get 18x squared. 2 times 9x squared is 18x squared. 2 times 24x is 48x plus 32, and rewrite everything else over, just like this. And so therefore, f of 3x plus 4 is going to equal, and then one more step and you're done, combine like terms, 18x squared. Okay, right? 48x and a negative 15x is a positive 33x. 32, a negative 20, and a negative 6 is plus 8? Plus 6, okay. Plus 6. All right, and so there's your answer. So f of 3x plus 4 is 18x squared plus 33x plus 6. Okay? So let's look at this example. Let's suppose let's say f of x, let's make it g of x. G of x, this is g of x, that's a g, is 5x minus 2. K of x is the absolute value of 5x minus 1 plus 3. H of x is negative 3x squared plus 5x minus 1. All right, write those three functions down. So you know that's function notation, right? So g of x, k of x, h of x, before we started this, normally stood for what letter? Y. Okay, so now I want you to find this. I want you to find, let's say letter A, I want you to find k of negative 3. K of negative 3. So how do you find k of negative 3? You go to your function k, because that's the name of my function. My name of my function is k here. This is function g, and this is named function h. So I want to find what k of negative 3 is. So you got to make sure you go to the correct function. So I got to go to the function k. And where we see the variable, what do I substitute? Negative 3. All right, so I'm going to go ahead and rewrite that function right next to it so I can draw the arrow. All right, so in place of x, I'm going to substitute negative 3, right? Okay, so I get the absolute value, you got to draw it, of 5 times x. What does x become? Minus 1. Whatever that absolute value is, I'm going to add what? 3. All right. Now, using order of operations, how do you deal with that expression? Huh? Okay, so inside that absolute value bar, you can think of the absolute value bar as a grouping symbol. I have a multiplication and a subtraction. What do you do first? Multiplication. So I get the absolute value of negative 15 subtract 1 plus 3. Absolute value of negative 15 minus 1. What's a negative 15 and a negative 1? Negative 16. What's the absolute value of negative 16? 16. And so therefore k of negative 3 is equal to what? No, 19. 16 plus 3. All right? And so remember, when you substitute just a number, you're going to end up with the number back, with the real number back. Letter B. Suppose I want to find g of 2 minus 3x. G of 2 minus 3x. So what do I do?
Multiply 2 minus 3x times 5.
Okay, so basically, wherever you see the variable x in which function, g, I'm going to substitute 2 minus 3x. So let me go ahead and rewrite that function g. So I rewrote the function g, and so underline what I want to substitute. So I'm going to draw an arrow to the variable x, and so I'm going to be substituting in 2. So I get 5 times in parentheses, what goes inside the parentheses,
2 minus 3x.
and then minus 2. Okay, next step.
10 minus
Next step.
10 multiplied.
So distribute, right? So I get 10 minus 15x minus 2. Combine your like terms, you're done. G of 2 minus 3x is going to equal
8 minus 15x.
8 minus 15x. Or you could say negative 15x plus 8, does not matter. All right. Letter C. Suppose you want to find k of 5x minus 2. K of 5x minus 2. So again, this time I'm going to go to which function?
K.
K. So I'm going to write the function k right next to it. So k of x is what function? What expression? Absolute value of 5x minus 1 plus 3. All right, so I'm going to underline 5x minus 2. That's what I'm going to substitute into the variable. I only see the variable once on the other side. So I'm going to get the absolute value of 5, and remember that says 5x, but what do I substitute into x? 5x minus 2, so put that in parentheses, minus the 1, so that's, make sure you understand this, so you said 5x, but x becomes 5x minus 2, and then you're subtracting 1, right? Absolute value of that, and then plus 3. All right. Now, look inside the absolute value bars. What do I do with what's inside? Distribute. So I get the absolute value of 25x minus 10 minus 1 plus 3 on the outside. Simplifying, combining like terms on the inside, I get the absolute value of 25x minus 11 plus 3. Okay, now listen carefully. When we did letter A, I actually simplified all the way because that expression right here was a numerical expression. I know that the absolute value of negative 16 is what? 16. Okay, but this is a variable expression here, so leave it like that. You can't just remove the absolute value bars. You can't say, can I take the absolute value of 25x and take the absolute value of negative 11? No. You can't break it apart like that mathematically. That's incorrect. So that's all you can do. So when you do the worksheet or problems with absolute value, you're going to see one in my math lab. Just remember that that absolute value expression stays. So k of 5x minus 2 is this. That's all you can do. That's it. Because you don't know what x is. All right, so notice the difference between A and B. I'm sorry, A and C. A and C. Okay, one more. Let's look at D. This time, let's say D, you want to find D, you want to find h of 3 minus 2x. H of 3 minus 2x. So this time, where do I go? To the h function or function h. I'm going to go ahead and rewrite it. So h of x is negative 3x squared plus 5x minus 1. So that was h of x. Okay, so what do I underline? What is it I'm substituting? 3 minus 2x. So I know what h of x is. I want to find out what h of 3 minus 2x is. So wherever you see the variable x in my function h, and I see it twice on the other side, I'm going to substitute 3 minus 2x. All right, so now let's do the substitution. So I'm going to get negative 3 times in parentheses, what do I put inside the parentheses? 3 minus 2x. What do I do to that binomial? I square it. plus 5 times in parentheses, we'll do a 3 minus 2x, and then minus 1. So that's where I'm at. So notice that in both of the variable x's, I have 3 minus 2x. Now you got to do some more work now. All right, so I got to get rid of the parentheses. So that 3 minus 2x squared, I've got to go and do some work there. So let's go off to the side and kind of figure out what 3 minus 2x times itself is, because that's what 3 minus 2x means. So here you're multiplying two binomials. So what are you going to do? FOIL. Okay, what's the first? What's the outer?
Negative 6x.
What's the inner?
Negative 6x.
And what's the last? 4x squared. Good. 4x squared. Combine like terms, what do you get? 9 minus 12x plus 4x squared. All right, so that trinomial goes where? Right here, right? This binomial squared. So, but all those terms in that trinomial have to be multiplied by what? Negative 3. So I get negative 3 times 9 minus 12x plus 4x squared. Then let's go ahead and distribute the 5 here. What does that become? Plus 15 minus 10x minus 1. What's the next step? Distribute negative 3. 2 more steps and you're done. So that's negative 27. What's negative 3 times the negative 12x? Plus 36x. What's the negative 3 times a positive 4x squared? Okay, and then rewrite everything else over. And so therefore, h of 3 minus 2x is going to equal, and let's just put in descending order. So put the x squared first. What are you going to write? Negative 12x squared. Now add the x's. 36x and a negative 10x is 26x. Now your constants, a negative 27, a positive 15, and a negative 1 is minus 13. Okay. All right. Okay, so that is evaluating functions. Okay, now there's one more or a couple more I want to do with it. Look at this that you picked up. You picked up this. So I'm going to go ahead and take that out. I want to look at number 2. We already know how to deal with number 1. We just talked about it. Let's look at number 2. So number 2 that you see here, that square root. So number 2, you have, let me write this number 2 from a handout. You have h of x is the square root of 3x minus 2 plus 5. And in part A, you want to find h of 7. Now I'm evaluating at a number, so my answer should be a numerical expression, should be a number, right? All right, so how do you deal with this?
The square, the same rate. We multiply.
No. Guys, what's the next step? That's what I'm asking. Substitute. So wherever you see the variable x, you substitute what? 7. We just did that. So I get the square root of 3 times 7 minus 2 plus 5, right? Okay, what's 3 times 7?
21.
So I get the square root of 21 minus 2 plus 5. What's 21 minus 2?
19.
So I get the square root of 19 plus 5. That is h of 7. There's nothing else you can do. Do not say the square root of 19 plus 5 is 5 square root of 19. You know that's not true, right? Because you're adding you're not multiplying. If this was square root of 19 times 5, then it'll be 5 square root of 19. All right, and don't say 19 plus 5 is 24. You can't do that because that's not 19. That's what? Square root of 19. If you look at your calculus, square root of 19 is not 19. It's 4 point something. Okay, so that's all you can do. Now, if you can simplify the square root of 9, if you can simplify the radical, go ahead and do that, but you can't simplify the square root of 19. So that's number 2, A. Okay, let's look at B, 2B. So in 2B, we'll go ahead and write the function over. So h of x is the square root of 3x minus 2 plus 5. So in 2b, you want to find h of 2. Find h of 2. All right, so what do? How do you find h of 2?
Substitute.
You substitute. Wherever you see the variable x, what do you substitute? 2. So I get the square root of 3 times 2 minus 2 plus 5. So all I did was substitute the 2. Now I've got to deal with the radicand. Let's simplify the radicand. What's 3 times 2? So I get the square root of 6 minus 2 plus 5. What's 6 minus 2? So I get the square root of 4 minus 5. But you can go further with this one than you can with the previous one, because you know the square root of 4 is, it's 2. So 2 plus 5 is what? 7. So therefore h of 2 is what? 7. All right, so notice that one with the previous one. The previous one, you looked at the square root of 19 plus 5. Here, though, you can go further because you've had experience dealing with simplifying radicals. All right, C. 2C. So again, my function is h of x equals the square root of 3x minus 2 plus 5. So in 2C, you want to find h of 3 minus 2x. Okay. Now, when we do that, think about that absolute value that we did earlier. So wherever I see the variable x, what do? What is it that I substitute?
3 minus 2x.
It helps if you underline it and draw your arrows. So I get the square root of 3 times, in parentheses, 3 minus 2x. Now, notice that in the previous 2, I didn't put parentheses around that because those were just numbers. 3 times 2, but you could have, right? Here you do need parentheses. Because what is it I've got to do with the 3 and the negative 2x at some point? Multiply by 3, by this number 3. All right, and then minus 2, and then plus 5. All right, now we got to simplify the radicand. So how do I simplify the radicand? Distribute the 3. So I get the square root of, tell me what to write, 9, good. Minus 6x, what else? Minus 2, and then on the outside I say what? Plus 5. Simplifying the radicand, I get what?
7 minus 6.
7 minus 6x plus 5. Just like if this was the absolute value of 7 minus 6x, you'd stop, right? Just like in the previous problem. Same thing here. You stop there. There's your answer. So what is h of 3 minus 2x?
Square root of 7 minus 6x.
Plus 5. That's all you can do. Can't do anything else. All right, just like with the absolute value we did a while ago. All right, let's look at 3b. 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 So in 3b, you have this. So my function is k of x is this fraction. It's in the numerator, you have 3x minus 2, the absolute value. And in the denominator is just x plus 2. And in 3b, you want to find k of negative 2. K of negative 2. All right, so what do?
Substitute.
Wherever you see the variable x, what do I substitute? Negative 2. But I see it in 2 places, right? I see it here, and I see it here. So every time I read x, I'm going to substitute negative 2. Now, since x is negative, I'm going to put in parentheses. So I'm going to get the absolute value. Don't just throw the absolute value away. The absolute value of 3 times x, what is x?
-2.
And then minus 2, right? Notice absolute value is still there. Divided by x, and what's x?
-2.
Plus 2, correct? Okay. Now, I get the absolute value in the numerator. That's going to be -6 minus 2, right? Divided by 0. The numerator becomes the absolute value of -8, right? Divided by 0. What's the absolute value of -8? 8 divided by 0. All right, now here's where we're at. What do you remember by dividing by 0? You had it on your previous test. 0 divided by a number other than 0 is 0. What's a number divided by 0? That's undefined. Remember that? That's undefined. Now, be a little bit careful. Don't say no solution here, because you're not solving an equation. This is not an equation. It says solve for x. That's not what you're doing here. So all you can say is this. Remember, you cannot divide by 0. So remember, you can't divide by 0. So you have to say it this way. So you're going to say k of -2 equal blank. You're going to say not a real number. That's all you can say. It's not a real number, because you can't divide by 2. Don't say no solution, because that's not solving an equation. You're not solving an equation. You're not solving for x. You're substituting into x. That's a difference. Solving for x and substituting to x are two different things. So that's all you can do. All right, let's look at A, 3A. In 3A, you want to substitute what number? 3. So wherever we see the variable x, what do I substitute? 3. So I get the absolute value of 3 times 3 minus 2 divided by 3 plus 2. Y'all agree you'll see what I did? Wherever I saw the variable x, what do I substitute? 3. Now look at the numerator. Inside the absolute value bars, what's 3 times 3? So I get the absolute value of 9 minus 2 divided by what number? 5. Notice I still have that absolute value bar. So that's equal to the absolute value of 7 divided by what? 5. But you know what the absolute value of 7 is. What's the absolute value of 7?
7.
And then so you get 7 over what? 5. So that is k of 3. So k of 3 is 7/5. So notice the difference between A and B. The steps are all the same, except in one of them you're dividing by 0. So you got to say k of -2 was not a real number. K of 3, though, is a real number. What is it? 7/5. All right, let's look at C. So 3C, again, we'll go ahead and rewrite the function. K of x is the absolute value of 3x minus 2 divided by x plus 2. All right, so in 3C, you want to find k of x plus 5. So wherever I see the variable x, what do I substitute? X plus 5. I'm drawing my arrows to the two x's that I'm going to substitute into. But you got to remember, the numerator has absolute value bars. You just can't throw those away. Okay, equal. The absolute value of 3 times, in parentheses, what do I substitute? X plus 5. And then I'm going to subtract 2. So that's my numerator. My denominator, what do I substitute into x? But I got to add what? 2. Good. All right, let's look at the numerator now. How do I deal with that numerator that's inside the absolute value bars? Distributive property, distributed 3. So I get the absolute value of what?
X plus 15 minus 2.
Good. The denominator is just what? X plus 7. Okay, good. All right, let's go back to the numerator. What do we have when I combine like terms? 3x plus 13. Absolute value, right? They're all divided by what? So remember what we did earlier in one of the previous problems. That's the absolute value of an expression. I can't do anything else to that. So I'm done. So the answer is what you see. K of x plus 5 equals this. Notice the difference between A and B, where I eventually got rid of the absolute value bars, and in C I didn't. It's still part of the answer. Because in A and B I was substituting a number. Here I'm substituting a variable expression. So in A and B I was substituting a numerical expression, a number, numerical number. Here I'm substituting a variable expression. The expression has a variable in it. All right? Okay, so that is evaluating functions. We evaluate functions at numbers and we evaluate functions at variable expressions. Okay? All right. Now, let's look at this.